Let's do it. So we were talking inequalities yesterday, right? Now we're going to talk about equations, but equations that involve absolute value. Do you remember what absolute value looks like? We've seen it. Oh, John, what were you going to say? This. Absolute value has the two bars, right? What does absolute value do to a number? It makes it positive because absolute value is a distance, okay? It's the distance away from zero, whether that goes to the negative side or the positive side. You're not going to have a negative distance away from something. It's not going to be negative 2 miles away, right? It's going to be 2 miles away. So absolute value will always make it positive, okay? So if I have the absolute value of x equals a, then this value of x could either be what's in here, a positive number or a negative number, because it's going to become positive either way, okay? So it's like saying if I said the absolute value of x is 7, that's the same as the absolute value of 7 is 7, or the absolute value of negative 7 is 7. So x could be 7 or negative 7, okay? By the way, when you have two answers that are the positive and negative of the same number, I'm totally fine with you writing it like this, plus or minus 7, positive or negative 7, okay? All right, so the first thing we're going to do is we're going to work with some equations where your variable is just on one side of that equation, okay? We're going to solve these. We're going to graph. Oh, I didn't graph them. We'll graph them. Sure, why not? But this will be your setup. So this first one, okay? We're saying whatever is inside your absolute value bars could be the positive version or the negative version of this number, right? So when you see absolute value bars, nearly every time, there are few exceptions, nearly every time, you are going to set up two equations, okay? Maybe you want to just write that really big at the top so that you don't forget to write both, because that's probably the most common mistake that gets made on these problems is people just solve it like a normal problem and they forget the second answer. There will be two answers in absolute value equations, okay? All right, so if that's the case, think about it. This has to either equal 5, so 2x minus 1 will equal 5, or that 2x minus 1 could equal what? Negative 5, right? I could say the absolute value of negative 5 equals 5. So this inside piece is either going to equal a positive 5 or a negative 5. That's all you really have to do. Now we just solve it. So to solve, we're going to go plus 1. So 2x equals 6, divide by 2. So x is 3. Okay, that's one answer. Or if we add over here, careful with negatives, right? Negative 5 plus 1 is what? Negative 4. We divide by 2. So x equals a negative 2. So x could be 3 or x could be negative 2, and it would make that inequality true. It's not inequality, absolute value true. Okay? It says graph. I don't really ever make you graph these, but here's how you would graph it. So if this is negative 2, 0, 1, 2, 3, x equals 3 would be here. X equals negative 2 is there. They're equations, so there's no arrows. There's no shading, okay? That's the only one we're going to graph because I really don't make you graph those. Okay, now, this one is slightly different. This one has absolute value, but it also has things outside of the absolute value. So we can't say right now that this equals 8 and this equals negative 8 because we've not isolated, okay? So that's the other thing you always want to make sure you do is you want to isolate the absolute value. Okay, what does it mean to isolate? Get it by itself, get it alone. Okay, so if we're gonna isolate the absolute value, we're gonna treat this like a normal equation. What's the first thing you would do to get just absolute value on the left side?
Distribute.
We're not gonna distribute. We wanna get rid of, not combine. What? Plus one, yeah, so we're gonna add one. Okay, think of it kind of like this. Whenever you see the absolute value, treat that like your variable, the thing that we're trying to get alone, right? If this was 3x minus 1 equals 8, you would add 1 first, right? We're trying to get the absolute value by itself. Okay, so 3 times the absolute value of x plus 2 equals 9. Have we isolated our absolute value? No, there's still a 3 outside, right? How do I get rid of it? What are we currently doing? 3 times, okay? If we're currently multiplying, what's the inverse operation? Division. So we're gonna divide by 3 to get rid of this guy and divide by 3. So the absolute value of x plus 2 equals 3. Have we isolated? Now we have, okay? So the idea is, once you've done this, once you've isolated, then you do the 2 equations. Okay, so from here, now we're gonna write 2 equations. We're gonna say x plus 2 equals 3, and x plus 2 equals what? Negative 3. Okay, so solve that. Take away 2, and x equals 1. Take away 2, and x equals negative 5. Okay, so 2 solutions, right? Because it's an absolute value problem. 1 and negative 5 are your potential solutions. Any questions on that? Okay, I want you to try letter C then. You may chat with your neighbor next to you. Who's got an answer for me? Negative 4. No. Negative 14. Negative 4, negative 14. Did you get that? Okay, here it is. Take away the 5. So you get a negative. Don't forget about that negative, right? X plus 9 absolute value equals negative 10. Now, it's tempting right here to add 2. But here's the deal. Absolute value bars act just like parentheses in terms of what operation we're doing. So a negative 2 next to parentheses implies multiplication, right? So this is multiplication. So we need to do the opposite and divide. So the absolute value of x plus 9 equals 5. Now what? 2 equations, right? Write the 2. The one is going to look exactly how you see it. The other one is going to change that 5 to a negative. Okay, so then we subtract 9 and we get x equals negative 4. And then subtract 9 and we get x equals negative 14. Good? Okay. Look at that problem. What do you see? A negative 12. Do you see an issue with that being a negative 12? Have we isolated? Yes. Our absolute value is isolated. So right now what this is saying is the absolute value of something is equal to a negative number. What's the problem with that? Absolute value always equals something positive. So if you have isolated and it equals a negative, what do you think your answer is? No solution. You cannot get the absolute value of something and get a negative number. Okay, so when you see that, that should be the easiest problem because you don't have anything to do. You just write no solution. Okay? Okay. So far, so good? All right. When we get variables on both sides of our equation, things get a little bit different. You have to check now for what are called extraneous solutions. Okay? Basically what that means, and you're welcome to write this, you don't have to. This is just answers that are not real solutions. Okay, so eventually you're gonna find ways that you can get a solution here, but they're not real solutions, okay? They're imaginary numbers or they're other things that you'll learn about down the road. For now, we're just gonna say that's extraneous and leave it at that. So let me show you what I mean by that. If you look at this first one, do we need to do something to isolate our absolute value? No, it is isolated. God bless you. What that means now, we have an expression on the other side, that 4x plus 5, okay? So this 3x plus 2, hold, 3x plus 2 could equal exactly what we see there, 4x plus 5, okay? But it could also equal the opposite of that, right? So if that was a 5, now we would set it equal to a negative 5. But it's an expression now. So what you do is you take the opposite of the whole thing, okay? So 3x plus 2 equals, so essentially we're thinking of it as this, the opposite of 4x plus 5, which would be a negative 4x and a negative 5. So basically whatever your sign is, positive or negative, you're going to change it. If it's a negative, you're going to make it positive. If it's a positive, you're going to make it negative for everything in the expression. Okay? Jessica.
So for everything, it would change the first part, so 3x plus 2.
This will always stay the same, right? But then you'll leave this as is for the first one, and then you'll change everything for the second one. Right? So it was 4x plus 5, now it's negative 4x minus 5.
Why don't we change 3x plus 2?
Because this isn't going to change what it is, right? It's what that equals that's either going to be the positive version of it or the negative version of it. Yeah, so you won't ever change the 3x plus 2. Okay, from here now it's just solve. So take away the 3x and then subtract the 5. So x equals a negative 3 for that first one. The other one, if we add 4x, we get 7x, and then we take away 2, so 7x equals negative 7, and then we divide by 7, so x equals negative 1. Okay, but remember, we said we have to check for extraneous solutions. Any guesses how you check for that? Plug them in, okay? That's all you gotta do, plug them in. So if I plug this one in, it's the absolute value of 3 times negative 3, plus 2. That has to equal 4 times negative 3 plus 5. Okay, if I plug the other one in, it's the absolute value of 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. Okay, your job is to see if those are true equations. So we plug it in. 3 times negative 3 is a negative 9. Negative 9 plus 2 is what? Negative 7, right? Equals, now simplify this side. 4 times negative 3 is a negative 12. Negative 12 plus 5 is a negative 7. Does the absolute value of negative 7 equal negative 7? No, right? Absolute value cannot equal a negative. So we say this is extraneous. Okay, so I want to see that answer from you, but I also want to see that you realized it was extraneous. Okay? Okay, now look at the next one. 3 times negative 1 is negative 3. Negative 3 plus 2 is a negative 1. So the absolute value of negative 1. Negative 4 plus 5 is 1. Does the absolute value of negative 1 equal 1? Yes, right? 1 equals 1. So that one checks out. So this is your true answer. This is your extraneous answer. Okay, we've got 7 minutes. Try that last one on your own. If you feel confident in it, you're welcome to get started on your homework once you finish that problem. I will talk you through it in just a minute, but try it on your own first. See if you can do it. Don't worry about extraneous. I mean, yes, check extraneous, but don't worry about telling me extraneous yet. What did you just get as your x values? X equals what? Oh, shoot. You did a different problem than I did. I don't know what the answers are. Are they weird? Maybe that's why I changed it. Shucks. Okay, we'll solve them together because I don't know what the answer is because I wrote it different on my notes and apparently never changed it on here. Shucks. Okay, so here's one, right? The other one is 5x minus 2 equals. How did you write your second one? Negative 7x plus 14. Shucks, really sorry. That was probably annoying, huh? Okay, so we would take away 5x and add 14. So this is divide by 2, x equals 6. Did you get 6? Yeah? Okay, second one. This is where I think it gets a little hairier. Add 7x. Add 2. It's not the worst. Divide by 12. So x is 4/3 or 1 1/3. But I have a feeling the extraneous thing is maybe where the issue. Did you check? Were any of them extraneous? 5 times 6 minus 2 equals 7 times 6 minus 14, right? So if you plug this 6 in, you get 30 minus 2, so absolute value of 28 would be 28. 7 times 6 minus 14 is 28. 6 work? 6 is good. 4/3, you're going to say the absolute value of 5 times 4/3 minus 2 equals... by the way, you always go back to the original to plug in. Did I say that before? Right? Plug it into the original. So 7 times 4/3 minus 14. So 5 times 4/3 minus 2 is 4 2/3. 4.6 repeating. 7 times 4/3 minus 14 is, oh, it did work. A negative 4 2/3 repeating. Positive or absolute value can't be negative, so this one is extraneous. Okay? Questions?